Hello everyone, welcome on our YouTube channel Physics Made Easy Kota. In this video lecture, myself Daljit Kaur is going to explain about some topics of the chapter alternating currents. So first of all, we are going to understand what is alternating current, what are its advantages, and what is the meaning of the root mean square value of alternating current or the mean value of the alternating current. Most of the electrical devices operate with alternating voltage. Electric supply for domestic, commercial, and industrial purposes is mainly alternating in nature. Alternating current or AC has many advantages over DC current. It is the electric current in which magnitude changes with time and polarity reverses periodically. The instantaneous value of alternating current is given by I is equal to I naught sine omega t. So it is look like a sine or a cosine wave current. Here the word I naught is a maximum value or a peak value or amplitude of the AC current, where omega is the angular velocity. We know the relation of the omega with the time period can be omega is equal to 2 pi divided by t, which is also known as a 2 pi nu, that is a frequency, and the variation of the AC is shown in the given figure. We can also calculate the instantaneous value of the voltage of an AC, which is given in the form of the sine equation, that is V is equal to V naught sine omega t. Here V naught is the maximum value of a peak current. There are the various advantages of the AC current. First of all, generation, transmission and distribution of AC is more economical. That is, it is less costly than that of the DC. The alternating voltage can be stepped down or step up easily. AC can reach distant places without much loss of electric power. Alternating voltage can be better controlled without any loss of electric power. AC is easily convertible into DC, and AC machines are small sized, having longer life and easy to use. So the mean or the average value of alternating current is that value of the steady current which is sent the same amount of charge through a circuit in a certain time interval. And to now for the derivation, we are going to get the expression for the mean or average value of alternating current. So now the mean or the average value of the alternating current. So for this expression, we need the value of the alternating current, that I is equal to I naught sine omega t. Then we take a value for the charge which is sent by the alternating current in a time dt. So this equation is from the equation of the current, that is current is equal to charge upon time. So by cross multiplying or rearranging the data, we calculate the small amount of charge dq is equal to I dt, that is equal to I naught sine omega t into dt. Then we calculate the charge sent by this AC current for the first half cycle, that is from the time 0 to t by 2. So we do the integration. While doing the integration, we apply the formulas of the mathematics and we come about the answer of the charge I naught t divided by pi. So now let's give a symbol IAV to the mean or average value of the AC over the positive half cycle, that is from t is equal to 0 to t by 2. Then the charge for this time period is given by Q is equal to the current multiplied with the time period. In the previous slide, we got the equation for the charge, and again in this equation, we again have the formula of the charge in terms of the mean or the average value of the AC. So we compare both these equations, and after now the next topic is a root mean square, or which is also called as the effective value of alternating current. It is that steady current which produces the same amount of heat in a conductor in a certain time interval as is produced by AC in the same conductor during the full cycle of a time, that is capital T. We use a two symbol. The first one we can use as a simple I, or the another one we use as a IRMS. So now we are going to derive the expression for the root mean square value of the AC current. First of all, we need the alternating current, and when this alternating current flows in a conductor, then heat produced in a conductor, and we use the expression of the heat, but we calculate the small amount of the heat produced in a conductor for the small time interval dt. We are aware about the value of the I, that is the alternative current. So put the value of the I in terms of the alternating current. Then we have to calculate the heat produced in a conductor for the complete time period, that is from t is equal to 0 to t is equal to capital T, by doing the respective calculations, that is by applying trigonometry equations. We got the final answer of the heat I naught square R divided by 2 multiply with T. So now give the symbol IRMS to the RMS value of the AC current which flow through the conductor of a resistance R for the time T, and we know that the heat formation or the heat produced in a conductor is given by the formula H is equal to I square RT, but we write this formula in terms of the IRMS current. So now we have the two equations of the heat again, one that we did in the previous slide and this one is the second equation. So just compare the both the equations of the heat and we get the root mean square value of alternating current. Now we are going to understand the important concept alternating voltage applied to a resistor. So in this case we only need a resistors to which a alternating source of voltage is applied, and the applied alternating voltage is given by the equation V is equal to V naught sin omega t. Let I be the current that flow in the circuit for a given time. Let us take the time small t. So we know the Ohm's law, apply the Ohm's law, V is equal to IR. By rearranging the terms we get I is equal to V upon R. Then we know the value of the V, that is in the form of the alternating voltage. So just put the value of the V in that form. So after this we know that V naught upon R, again there is the application of the Ohm's law. So we can apply the Ohm's law here. So this is equal to I is equal to I naught sin omega t. Here I naught represent the V naught upon R, which is called the peak value of alternating current. So now phasor diagrams and phasor. So what is phasor? Phasor is a rotating vector which represent a quantity varying sinusoidally with time, such as alternating current and alternating voltage. The phasors has magnitude as well as direction, and the direction is known as a phase. It is represented by a line whose length represents the peak value of alternating quantity. The peak value of alternating quantity is called the magnitude of the phasor, representing these quantities, and the direction of the phasor with x-axis is called phase of the phasor, and it is measured in the anti-clockwise direction. The phasor rotates freely about a origin, or we can say it about a point which is taken as a origin in anti-clockwise direction with the angular velocity, and the anti-clockwise rotation of the phasor is taken as positive, while the clockwise rotation of the phasor is taken as negative. So here is a diagram which is known as a phasor diagram. This diagram shows the phase difference, that is a direction between the current and the voltage. So what are the phasor diagrams? Phasor diagram is a graphical way of representing magnitude and directional relationship between two quantities of same frequency varying sinusoidally with time. The phase difference between these two quantities is represented by the angle between their maximum value.